All the basic fundamental particles of nature, they have a matter version and an antimatter version. And what we do here at LHCb, one of our specialities, is looking at the difference in properties between matter and antimatter. Now, the result that we've released today is looking at a particle called a D0, which contains a charm and up quark, and the antimatter equivalent of this, the anti-D0. And what we find is that this D0 particle can oscillate into its antimatter equivalent by some fascinating quantum mechanics. The rate at which this oscillation between the D0 and the D0 bar happens depends on a tiny mass difference between particles. This tiny mass difference is 10 to the minus 38 grams. That's 0 followed by 37 zeros, 1 grams. And it's this tiny number which is controlling the rate of oscillations between the D0 and the D0 bar. Now, actually, this is controlled by some really fascinating quantum mechanics. And what's really happening is that we have a state which is a mixture of D0 and D0 bar. You might be familiar with Schrodinger's cat, where you put a cat into a box and then afterwards the cat is a mixture of alive and dead. It's like that. We have this, which is a mixture of D0 and D0 bar, and when we open the box at later times, maybe we see a D0, maybe we see a D0 bar. So it's a really fascinating result that we have today, but it's also a window for the future, because we want to use this to be able to study differences between D0s and D0 bars, between matter and antimatter, and we can study these differences between antimatter and matter using these oscillations that we've observed today.